Before we begin this Microsoft Digital event, we would like to acknowledge the traditional custodians of the land on which we live and work throughout Australia, as well as the Aboriginal and Torres Strait Islander people viewing this event today. We pay our respects to elders both past, present and emerging, and recognise and celebrate their continuing connection to land, waters and community. Our reverence also extends to all First Nation and Indigenous peoples, as well as their ancestral lands.
Hi everybody and welcome to another great episode of New Breakpoint. My name's Simon Waite. On today's show we're joined by Graeme Foster from our Perth team who's going to talk about Azure Active Directory and JWTs. We'll get a bit more to his topic in a moment. If you do want to ask questions during today's show, please make sure to put them into the Q&A window and we will get to them either during the show or at the end of the show. We'll pick a couple of the really best questions that we see and we'll have a live Q&A at the end of the session to answer that question and potentially others that might come up during the show. If you do want to share the resources out of today's show, the link will be published up on our show notes on GitHub. The link to that will be available at the end of the show in the Q&A window. And also we'll share the additional resources and a link to this video a couple of days after we've aired this episode when you're watching it. And if you are watching this on replay, welcome. I hope you enjoyed today's episode. So, as I said, we're joined by Graeme from Perth. Graeme's one of those great people on our team that has a wealth of experience of building and designing software and just building and designing software in regulated industry. Now, we all know that at the core of most great applications these days is user identity and, in fact, application security. And the most common way we see that happening across the industry these days is using OAuth or OpenID Connect. Or a combination of those implementations. And sometimes as a developer, it can be a little bit hard to wrap your head around what OAuth flows are, what JSON access tokens are. So I think today's show is going to be a great one. So if you've been doing any form of identity integration into your applications, stick around because we've got some really good insights coming up for you. So without further ado, let me get Graeme onto the show so he can start his great demo-laden session, which I'm sure you're going to enjoy. And I've seen a quick view of this demo just a moment ago, so I'm really looking forward to seeing how it goes. Hi, Graeme, and welcome to New Breakpoint.
Hey, Simon. Yeah, it's great to be here. Really looking forward to the show today.
Look, as I said up top, really interesting topic. Do you want to tell us a bit more about yourself, your experience, and a bit about the topic that you're going to cover today for us?
Right, absolutely, yeah. So my name's Graeme, and I work as a cloud solution architect for Microsoft, and I am based out of Perth in Western Australia. Now, I've only been at Microsoft for about a year now, but I've got about 25 years in the industry, and I have seen many different ways at doing authorization and authentication come and go over those years, from very simple to very, very complex approaches. So today what I'm going to do is I'm going to have a look at Azure Active Directory. And in particular, we're going to dive into concepts like OAuth and OIDC, JWTs, PKC, and all these kind of really exciting sounding acronyms. Now, what I don't want to do is give you a kind of 101 introduction how to set up a working sample, because there's a lot of really good content out there on the internet that can take you through that. Instead, what I want to do is I want to focus on a slightly different aspect, which is what can go wrong when you're actually trying to get these samples up and running. Now, it's not unusual in my job to get called into queries or support questions around Azure Active Directory when it's not working properly. And what I find is that the issues that we see, or the confusion, tends to fall into about 3 different categories. So what I want to do today is start off with a fictitious sample application which isn't working properly. And I want to go through the kind of classes of problem that I see. I want to show the tools and approaches that I use to try and track down and debug these problems. So my hope is that by the end of this session, should you be running into problems with Azure Active Directory in the wild, you'll have that little bit further, deeper knowledge of where to look and how to go about debugging your issues, which hopefully will help you to solve them quicker. So what I'd like to do is switch to our sample application that we're going to use to go through these issues today. Okay, everyone. So because we're broadcasting this in December, I thought I would put a bit of a Christmas slant on today's demonstration. And I'd like to introduce you to Santa Webb, which is Santa's present management application. Now, inside Santa Webb, Santa can do things like record children onto his naughty nice list and work out all the logistics for present delivery over Christmas. So it's a very, very important application, as I'm sure you can tell. Now, Santa happens to have some crack teams of elf developers, and they've done some brilliant work on this application this year to migrate it to the Azure North Pole data center. So the first thing that they've done is they've outsourced the authentication to Azure Active Directory. Santa Webb used to store its own usernames and passwords, but it else realized that it would be a much more secure thing to use Azure Active Directory instead. And they've switched to what we call an OpenID Connect method for authentication. And we'll look at that in more detail as we go forwards. When the elves did this, they also realized there was this thing called Web 2.0, and it would be a brilliant idea to create APIs to expose all the complicated functionality that Santa Webb has. Logistics of present delivery and naughty nice lists are obviously quite complicated business processes, and you wouldn't want to rewrite those. So what they've done is they've exposed APIs and they've protected those using OAuth 2 as an authorization mechanism. Now, it just so happens that there are some elves in the digital transformation team who really hated the user experience inside Santa Webb. So once they saw these APIs, they decided to create Santa Lite. It's a single page application skin over Santa Webb. And it also uses OIDC to authenticate Santa and the elves, but it also uses OAuth 2 for delegated authorization to call those APIs. Now, this is all up and deployed, but they've got a whole bunch of issues with their OIDC and their OAuth 2. So we're going to see if we can help out the elves. So let's flick to the application and have a little look around what's going on. Okay, so we can do a fade there, I think, as well. Perfect. And then here we go. Okay, so this is what Santa Lite looks like. As you can see, those elves are pretty good UX engineers, and they've created a beautiful looking skin over Santa Webb. Now, they've done it using React, and they've used a very, very vanilla React application. But to get the authentication and authorization working, they had a choice that they had to make up front. Now, when you want to authenticate against Azure Active Directory, there are two libraries that you could choose from. The first one's called ADAL, stands for Azure Active Directory Authentication Library. And it's quite old. And in fact, the actual packages have been deprecated and not been worked on for many, many, many months. There are some scenarios that it does support, but the elves, I think, made a really good choice, and they chose to use a package called MSAL instead. Now, I mentioned ADAL because I could see there are over 250,000 downloads of that package on NPM last week alone. So a lot of those were actually from a version 4 years ago. So, for security reasons and because MSAL supports much newer and more modern flows, and we'll look at some of those in a minute, if you're on ADAL and you can, I really recommend that you look to switch over to MSAL. But the elves started with MSAL, and this is what we can see now is their very, very simple configuration that they've had to use to get up and going. It's really, really, really straightforward, but there's a couple of really key things I just want to point out first of all. So the first is, for any Azure Active Directory authentication, there are two really important pieces of information we need. We have what's called the client ID and we have the authority. Now, Azure AD is a multi-tenant authorization system, and there are many different companies that host their authentication purposes on there. The authority is the thing that tells AAD which tenant it is that we're actually inside. So in this case, 492F24 is Santa's AAD tenant. Now, the next thing is for any Azure Active Directory application, we have this thing called a client ID. Now, when you're inside the tenant, your tenant may host hundreds, if not thousands, of different applications, and each one has got a GUID that represents it. In this case, we have Santa Light represented by A41, and I've got that on the portal over here, so we can see it here, A41. So there's the configuration, here's the portal, and let's go and have a look at the else first problem that they've got. So Santa Light has got a big sign-in button, so we can say whether we're Santa or one of the else. So let's click on that and see what happens, and we'll find the else first problem with AAD. So we're going to select Santa, that's who we want to sign in as. And what we've done is we've been taken away from Santa Light's website, and we've gone to a site hosted by login.microsoftonline.com, which is Azure Active Directory. Now, we're doing authentication here. So what we're being told is that the application would like to sign in and read our profile. So we're going to accept that and see what happens. Yeah, right. Okay, so straight away we can see we've got a problem here. We're being told that the reply URL specified in the request does not match the reply URLs configured for the application. Now, this is a fairly simple one, but I do see this a lot in the wild, and it pays to think about what's going on here. Now, Santa Light has taken us to Azure Active Directory to sign in. We do the authentication process inside AAD, and then AAD needs to send us back to our website. That's where the reply URL comes in. Now, if we go back to our configuration inside the application, we can see that we're telling AAD to send us back to santalight.localtest.me. So let's go into AAD and see what's happening there. Now we can go into the redirect URIs, and in here we can have a look at the ones registered for our application. And we can see straight away that there's a problem. Looks like Santa Light maybe used to use ASP.NET Core, because this is a common path you will see in ASP.NET Core applications. But in this case, it's not right. Now, all we actually have to do to fix that is delete that and go again. But there's a couple of really important things to point out here. Now, the actual path part of this is case sensitive. So that's one thing that I see trip people up. The other thing is trailing slashes as well. Now, in the OAuth specification, it's really important, and it calls out that the redirect URI registered inside AAD must match the one registered here. It protects against some security problems. So in our case, if they don't match absolutely perfectly, then it's not going to work. All right, so now we've sorted out that redirect URI. Let's do the sign in again and see what happens this time. So we can go sign in, we can go and select Santa, and we get brought back to our application where we have welcome Santa. Now, what I want to do is take you through some of the URLs that were actually hit in making that authentication work. I think it's really important to have a look at where AAD is taking us to and the information that we're passing in. Now, there are two main ones that I want to focus on. We have calls to what we call the authorized endpoint, and then we have a call to what's called the token endpoint. Let's start with the authorized. Now, if you're coming from older versions of OIDC, this might look a little bit unusual for you for a single page application, because normally what you would do is you would request what we call an ID token from Azure Active Directory for what we call the response type. Now, this is a flow that was called the implicit flow in Azure in OAuth 2, and it's actually being frowned upon now. There are some potential security holes around it, because if you remember how Azure Active Directory redirects us back to our application, when we use the implicit flow, it redirects us and sends us a token. And the problem is that token could get leaked from browser history or could get intercepted along the way in other ways. Now, just recently, there's been a new flow which has been introduced, which is called code plus PKCE. And it allows a single page application to work more like a web application when it comes to its OAuth 2 flows. And here's what happens. We start off, and there's some common things we can look at. We tell AAD who the client ID is, we have the redirect URI as per usual, but we ask for a code instead of a token. Now, a code is something that can be switched out for a token at a future point in time. But the key is that to switch the code out for a token, we need to provide AAD with something secret. What PKCE does is it introduces the concept of the code and the code challenge. Now, the code is a one-time secret created by our single page application. And what we do is we create a SHA of that and we send it up to AAD. AAD binds that SHA with the code that it sends us back. So when everything's completed on this flow, we end up with, and see if we can find the right flow in here, AAD sending us back with a document location replaced to do the redirect, but instead of passing us a token, it passes us the code. So as you can see, if somebody steals that, it's fairly useless. So we close the security hole. Now, what we can then do is we can use a common endpoint from AAD servers called the token endpoint. Now, when we use the token endpoint, what we're doing is we're sending AAD a code. In this case, this is the code that it sent us a minute ago, but we're also going to send it what we call the code verifier. Now, the code verifier is simply the plain text where we sent the SHA to AAD originally. When AAD receives that, it knows that the only thing that could have had that plain text is the thing that sent it the SHA in the first place. So we've bound the request to the code to the request for the token, and we've enabled a really secure flow to get tokens down in our single page application. So what did we get sent back? Well, there's a bunch of tokens in here, but the one that I want to focus on is the one called the ID token. So let's grab that and have a look at it in a tool called JWT.ms. So I'll just extend my browser. I've got a few of these open because we're going to use a few of them as we go through. So every JWT really breaks into three components. Let's call it the red component, the blue component, and the green component. Now, the red and the green components are concerned with digital signatures. When we get a token from Azure Active Directory, we want to know that it was from AAD. So what happens is AAD signs that token, and it gives us some information about the key that it used to sign it. We can go back to AAD and find that public key and validate the signature and therefore trust that the token came from AAD. Now, there's some important claims in an ID token to go through. So we'll start from the top. We have the audience claim. Now, the audience in an ID token matches to the client that wants to use the ID token. In this case, it's this magic A41A, which we can see is the client ID of Santa Light. Now, if you get a token and it's not your audience which is inside that token, it's really not intended for you. So you probably shouldn't use it and make decisions on it. Now, the other important things for Santa Light here are the name, and we have the preferred username. This is the authentication aspect. We're being told who this person is that is trying to sign into our application. Now, there's one other thing that I'll call out inside here, which is the version down the bottom. Versions in Azure Active Directory can be a little bit confusing. There are two versions of our endpoints, V1 and V2. Now, when it comes to ID tokens, there's a fairly simple rule. If you request an ID token from that version 1 endpoint, you will get a version 1 token. If you request a token from a version 2 endpoint, you will get a version 2 token. There aren't too many differences between them, but the version 2 endpoint is a little bit smaller and contains a few less claims inside it. But look, that's enough to get our authentication working. So we're going to move on to authorization and have a look at some of the problems that we can see there. Now, Santa Light is fairly simple at the moment. We've got one option, which is to add Graeme to the naughty nice list. So let's do that and see what happens. Now we're going to kick off another flow with Azure Active Directory. We're going to put our username in. It's a fairly high privilege operation is this. And what we get asked for is some permissions. Now, the important ones in here are the app wants to manage the naughty nice list. But in brackets, we see Santa Webb. Now, Santa Webb is the application representing the APIs inside AAD. If we go over to Fiddler, we can have a look at what happened here and see some of the properties that have changed in the request. It's a call to the authorized endpoint in the same way that we did with the sign-in. But the main difference is that instead of asking for the OpenID scope, which drives OpenID Connect, we're asking for this one, API Santa Web presence.naughty nice list. Now, if we go into Azure Active Directory, we can see on the Santa Web application that we have this property, this button here says expose an API. Now, if we click on that, we can see that there have been two scopes that have been advertised from Santa Web. Santa Web Presence Deliver and Santa Web Presence.naughty nice list. Now, it's the first important point about scopes is this. Santa Web probably has a couple of hundred different endpoints because there's a lot of functionality which is exposed from it. Now, scopes, you've probably heard that term from OAuth 2, are something that we want to present to an end user that can give a nice experience when we're asking for their consent to do something. So it wouldn't be great to have 200 different scopes. Instead, we tend to group them up into bigger buckets such that we can drive a nice user experience. And that's what's happened here. We've got the presence deliver scope, and we can see from here that we have asked permissions to access that. This is also called delegated consent. If you go back to the old days, if Santa Light wanted to call Santa Webb, we might have given it our username and password. This is going back many, many, many years, so I'm sure no one's done that in a long, long, long time. But that's obviously a security nightmare. So delegated consent gives Santa Light the permission to ask us for consent to call Santa Webb on our behalf. So as far as Santa Webb is concerned, the context of the call will be us. So let's upset the scope and see what happens with our token endpoints. So we'll pull Santa Light back up. Now, there's a few things we're going to have to deal with, but the first thing is, let's go and have a look and see where the problem has come from. Now, in this case, we can see that we've called the token endpoint from AAD, and we can see that things actually look pretty good up here. AAD has sent us back an access token in this case. And an access token is the thing we're going to need to call the Santa Webb APIs. So that looks okay, but we've still got an unauthorized problem here. So what I'm going to do is paste this access token into JWT.ms, and we'll have a quick look at it. So the things I want to call out that are different from the ID token. Straight away at the top, the audience in this case is API://Santa Webb. Now, if we go back into our Active Directory configuration page for Santa Webb, and we go into the Expose an API page, we'll see at the top we have this application ID URI, which is API://Santa Webb. So that all lines up. Looks fine to me. The other thing is we can see that we have got a SCP claim, which stands for scope. So we can use this to see what Santa is actually consented to. And in this case, it's to add to the presence naughty nice list. So again, that looks pretty good to me. So I think in this case, we're going to have to go to the API itself. So let's open up Fiddler and see if we can find anything in the logs of the API. Now, there's an error down here. Hopefully you can see this, but I'll read it out in case you can't. It says, bearer was not authenticated. IDX 10214, audience validation failed. Okay, that's interesting. So it's something to do with the audience. We've got API Santa Webb. Now, this is one of those real quirks of MSAL. When you configure MSAL in your APIs, it's actually not important for you to tell MSAL about the audience. If you don't tell it what you expect that audience to be, it will use some kind of magic rules to make a decision for you. And it will either expect an audience, which is related, which is the same as the client ID, 86cc, or is a kind of nice looking string that says API:// and then the client ID. Now, this is due to inside the portal, when you go and create a new application, it will offer you a default URI for that. And it will be API:// the client ID. So that's where the magic strings come from. Now, I had to actually debug through the code to find that out, which is interesting, but the code's up on GitHub. So you can see that there's actually two pathways, and depending on the versions of the token is going to make a difference to what audience is expected. But what we can do is we can uncomment this line here and tell our API what the audience actually needs to be. And this time we can go and try that operation again and see if Santa can add to the naughty nice list. So API is running. We'll go and do the consent again. Oops, we need the password. Consent to the permissions. And let's see what happens. Perfect, we've added Graeme to the naughty nice list. So that was great. We consented, we got a token back, we called the API, and everything was okay. Now, there's a little problem with this though. One of the elves is a little bit mischievous in Santa's elf's friends. So let's see what happens when that elf logs into the application. So we'll go back, we'll do the OIDC flow again. Now this time we're going to log in as Alabaster or Snowy the Elf. So we'll do that. Alabaster Snowball, sign in. set the scopes. And Snowy realized there's a little UI glitch inside the application. He still gets access to add Graeme to the naughty nice list. So when we click on that, what we're going to see after we put the password back in is that Snowy can still consent to manage the naughty nice list. Now, it's a really important thing to know about scopes, especially with AAD. There's no links between scopes and the subset of users that are allowed to access those scopes. A scope is nothing but a way to carve up your API so that you can ask for consent, but it's got no real authorization or authentication around who can access that scope. AAD just doesn't store a link between them. So in this case, it's perfectly okay for Snowy to go and get the scope to manage the naughty nice list. And when he does so, he adds Graeme to it. So the thing to remember here is that scopes are not permissions. It's a really important thing to remember about OAuth 2. A scope is not a permission. Now, if you think about building applications in the past, you might have used concepts like RBAC or role-based access control to build the authorization around them. With RBAC, what we do is we divide our users roughly into roles, and then we give those roles permission inside the application. Now, we used to do this with Active Directory groups a lot. And the problem with that is that it could lead to AD group explosion, where you might end up with thousands of different groups representing your different applications in your estate. Now, what we don't want to do is recreate that up in the cloud if we can help it. So it just happens that Azure Active Directory gives us a way to be a little bit more specific about roles against applications. And it actually allows us to create roles on applications. Now, in this case, let's see if the page is going to come up. Might just have to click the refresh button on that. We've got two roles that we've defined against Santa Webb. They're fairly broad. We have Santas. There's only one Santa, I know that. And we have the elves as well. So we just happen to have already put Santa inside the Santa's role here. So if we go to overview, it's a little bit confusing. We actually have to go to this managed application in local directory where we can go. Oh, we haven't. So let's assign Santa to the Santa's group. We can click on add user or group, select Santa, hit select, hit role, and we'll put him into the Santa's. So what I want to do now is show you what's actually happened to the tokens behind the scenes now that we've put Santa in that group. So we'll go back, we will sign out our elf and put Santa back in. So we'll choose Santa. I'll grab his password for in a minute. Click on the add Graeme to naughty nice list. Accept. And we'll go back to our browser, and this time we'll grab the token that's popped out here into jwt.ms. Now, the only difference between this token and the last one is that when you are a user or an application inside a role declared against a AAD application, when you request a token for that, those roles will be sent back in that token. So now we can use this to start to make authorization decisions in Santa Webb. Now for ASP.NET applications, ASP.NET Core, sorry, those roles are actually translated into fairly standard ideas that we've had in ASP.NET Core. So we can use the authorize attribute and just say that this operation actually needs somebody to be in the role of Santa to permit that. Now, if we run it again, we'll get the different behavior where Santa can use this operation. And we'll get Santa a token. But if we were to log in as the elf, then we wouldn't be able to do that. The role wouldn't exist and we would get forbidden, which is the behavior we're looking for. Okay, so there you go. So I've taken you through a few different classes of problems and confusion that I see inside of AAD on a fairly often basis. We've looked at simple configuration issues. We've looked at the PKCE flow and talked about how it's different to the implicit flow and more secure. Talked about ADAL and MSAL, and we've talked about scopes and roles and how scopes aren't permissions. So with that, I'm going to hand back to Simon. Now, I have a bunch of links that I can share as well that go through a lot of this stuff in more detail. So thank you.
Graeme, thanks a lot for that. That's a really great overview of what I think sometimes can feel a bit like a black box to developers when building applications.
Yeah, absolutely. Yeah, there's a lot going on in there, isn't there?
Look, I heard at the top there you talked about the L's deploying to the North Pole Region 1. The burning question I've got about that is that region cooled by ice? Is it naturally cooled, or are we using cooling from somewhere else, do you think?
Yeah, so look, when I thought about the North Pole data region, I instantly thought about the submarines that we submerged into the ocean a couple of years ago to keep them cooler. So I'd like to think that it's a kind of maybe a sleigh up in the atmosphere or something, which has got the data center up there.
Yeah, I think in Scandinavia somewhere, I think we're using natural cooling in some of the data centers. I want to say Norway. I think is the right location. It's a super interesting space. Look, I've taken this talk today off topic by asking that question. I'm going to start by asking a question. You obviously used a few different tools there. You're obviously debugging your application locally in VS Code, but you used, I think I saw Fiddler in there as well.
That's
and
right, yes.
A website for doing tokens. What are the sort of the tools that anybody really needs to have available to help troubleshoot these sorts of issues that you're seeing?
Right. So there's a few tools that you just mentioned there. So every time I've got an application which is making HTTP style requests, then I will always have Fiddler in my toolkit. It's a really brilliant debugging proxy, and you can just run it and literally start to have a look at the HTTP traffic, which is traveling backwards and forwards between your applications and the APIs. And there's so much information that you can get inside here. And it just gives you a real insight into what's actually going on behind the scenes. Now, when it comes to anything OAuth related, I've got this site called JWT.ms, which is my go-to site. So this is one where we can just drop in a JWT and it will decrypt that, it will decode that for us. It's all just base 64 at the end of the day. Now, the really nice thing about JWT.ms is that it has this claims tab down here as well. So it doesn't just tell you the claim name and the claim value, but it actually gives you a fair bit of information around what that claim is and how it should be used. So again, a really useful tool for understanding what's inside those tokens, especially if they're not working properly.
And I know Fiddler is particularly useful, but I think if I recall correctly, it's primarily on the Windows platform. That may have changed in the last few years, but there are equivalent tools that you can find for Mac and for Linux as well if you're looking for that. And I guess you could ultimately use your browser dev tools as well if that was the only tool that you had available to you. I guess you could go in and grab the response out of that as well if you needed to.
Absolutely. Anything that's going from the browser, you can use your debugging tools inside to actually have a really good look at those as well. I think in the past as well, I think it was Charles was a debugging proxy that I wanted to use on the Macs. Yeah, so similar kind of thing. That's right.
I guess the question we haven't chatted about before, but I'm going to put it out there. So I know the first time I started working with JWTs and I discovered JWT.ms, and I think there are a few others. I think there's JWT.io as well. That does similar sort of thing. I always blew my mind that I could just copy that base 64 encoded string and drop it into a window and then see the contents of it. And as a developer, you go, well, at what point am I actually getting security out of this thing if notionally anybody could snoop it and do this exact exercise? What's your response to that?
Yeah, look, it's a really good call out. So I think there's a few things that we can mention around the tokens today and talk about some things that are coming in the future as well. So you're absolutely right. This token is like gold, basically. You don't want to let anybody get hold of that. So that's why OAuth 2 as a framework specifies that everything has to be over HTTPS. And then things like PKC are coming along to further strengthen that binding between the thing that requested the token and the thing that is that received the token. Now, there are a few things that can help if you're a bit uncertain about exposing that information inside that token, or you're just a bit worried. There's a concept of reference tokens that some token servers allow, where instead of passing the token backwards and forwards, it just passes an opaque string. And that string, if you think about it, it's just like a key value lookup inside the token server itself. So that's one thing you could look at. There's also a concept of JWEs. So JWEs are encrypted JSON web tokens. So they're actually encrypted using keys on the server itself. Now, I believe that AAD has got support for that. I remember reading a post about this recently. I'll have to dig out a link for that.
But there's one in the show notes for sure.
Yeah, awesome. And there's one thing which is coming, which is a new idea called proof of possession. So again, this is to do with another potential security hole, which is how do you know the thing using the token is the thing that received the token in the first place? So proof of possession is a way that you can actually bind, again, something secret that the client has with something inside the token itself, such that when you try and use that token, you have to send maybe a public key, or sorry, a private key, something signed with a private key that can prove that you were the thing that possessed the public key that's embedded inside the token. So there's a lot of interesting things coming along in that space at the moment.
We do have Graeme sticking around for a live Q&A, which we'll be hopping to in just a moment. So if we haven't answered your question, or you've got some additional questions out of this Q&A section here, please do hang around. We're looking forward to answering your questions. There are show notes that we published that'll have all the useful links and follow-ups from Graeme's great talk today. But look, I'm going to say thanks for doing the demo, and I'm looking forward to seeing what questions you've got in the live Q&A. So let's hop over there now.